Unit 7 review, graphing quadratics. So we said front page is all standard form, which means we start off by labeling our ABC. What's A? 1, what's B? And what's C? Perfect. Easy start, okay? Now we've got to find the vertex, okay? We have to use a certain formula to find the vertex. And it's just to find the x value. It's x equals negative b over 2a. If I plug this in, what would a negative 6 be? Positive 6, and then 2 times 1? 2. So what is 6 divided by 2? 3. So x is 3. That is the x coordinate of my vertex. Okay? But I don't know what y is. So what do I need to do? Plug it in. Yep. So y equals 3 squared minus 6 times 3 plus 9. Make sure you type it in just like that to your calculator. Whatever you do, it won't really make a huge difference on this one, but make sure you shut your parentheses before you square that first term, because if it was negative and you put the square inside, it would count it wrong. It'd give you a wrong number, okay? So make sure you type it in just as you write it. And what do you get on this one? 0, perfect. We can go ahead and plot that point. And then we can draw our line of symmetry. Definitely helps if you're a visual learner. You don't have to draw that line of symmetry, but it is, again, very helpful. Okay, I only have 1 point. I need to have a total of 5. How would I find 2 easy ones? You could pick 2 random points and plug them in, okay, and that's what we're going to end up doing anyways. But which one of these values, A, B, or C, tells me the slope of the first point? A. A is the slope of the first point. If you did not remember that, write that to the side. A equals slope of first point. Okay, so I can go up 1 over 1 and then also reflect that over. So now I have 3 points, but I need 5. So I just need to find 1 more and then reflect it, correct? It does not matter what I pick. I just can't pick any of the numbers that I've already used. So 2, 3, and 4, okay? If I were you, looking at this, do I have my y-intercept yet? No, I don't, okay? So since I know I'm going to have to plug in 0 anyways, I'd go ahead and just do that one, okay? So y equals 0 squared minus 6 times 0 plus 9. It's okay if you didn't pick that one. That's totally fine, but you'll just have to go back and do this later on anyways, okay? So when you plug that in, what do you get for y? 9. So your y-intercept is just 0, 9, which is right up here. Reflect it over. And now I'm done graphing. So that is what my quadratic should look like. If I look at that vertex, would you call that a max or a min? A min, right? It's the bottom of a hill, so it would be the min. Okay? Now we look, this is a quadratic, so the domain is always going to be negative infinity to positive infinity. Perfect. What about the range? This one has caused some confusion in the past, so I want to talk about this. Okay? Domain is always far left to far right. Are you with me? So we can see that these arrows are going left forever, right forever. That's why it's negative infinity, positive infinity. Okay? Range works the same way, but it's the y-axis instead. So we're actually going to start at the bottom, and we're going to go to the top. So if we look, we can see that this starts right here, correct? At this point, this vertex point. What is the y value of that? 0, and we see it goes up forever, correct? Okay, so on the y-axis, that range is going to be 0 to infinity. Perfect. Okay. Then we look, x-intercepts. X-intercepts are where we cross the x-axis. Can I see that on my graph? Ooh. Yeah, I didn't graph this perfectly, but my vertex is on the x-axis, right? Will that happen every time? No, it will not, okay? But in this case, it did, so that saved me a lot of time. And it also got me an extra credit point, okay? All of the x-intercepts on this test are going to be extra credit points. So, the easy ones like that, you better do them, okay? They are going to get a little more difficult, but always at least attempt them, okay? Because you're not going to get them wrong, but try to get some extra credit on this test. Definitely will help you, okay? And then lastly, increasing, decreasing intervals. There's also been a lot of confusion on this, okay? So here's what I want you to think when you see the intervals. Okay, to the left forever would be negative infinity, right? And to the right forever would be positive infinity. And this line of symmetry, so we can see that's where we kind of change direction as far as this graph. So it starts to go down or decrease, right? Kind of if we talked about if we had a man that was running, okay, and he started running, he'd be starting to decrease, and then he'd turn at that line and start to increase, okay? What number is that line going through? 3. Sometimes it helps me to just label that, okay? So now I can see from negative infinity to 3, I am decreasing. Negative infinity to 3, I am decreasing. And then, picking right back up where I left off, from 3 to infinity, I am increasing. And I'm done. Bless you. Okay, so make sure that you have all of that down. Let's make sure we have all of that copied down. Free answer. Any questions on that? No? Okay, we're going to go ahead and do number 2 together as well. Okay, we start off, this is standard form, so tell me, what do I need to write down first? A, B, and C. What's A? What's B? What's C? Perfect. How do I find the vertex? X equals negative B over 2A. Negative B. It's going to be a positive 4, right? Because the negative 4 is the positive 4 divided by 2 times negative 2. What is 4 divided by negative 4? Negative 1. Watch your signs. Good. That's the x value of your vertex. Questions on what we've done so far? Is that pretty simple? We think we can remember that? Okay. Good. Then we got to find what y equals, right? How do I do that? Plug in the negative 1. And again, this is where it's super important to close that parenthesis in your calculator before you square it. Okay, because it's going to give you the wrong number if you don't. What do we get? 8? Everybody get 8? Got 8? Okay, cool. Negative 1, 8 would be right here. Go ahead and put your line of symmetry through that as well. Easiest way to find 2 more points is to use the A value, the slope, right? Be careful on this one. What is the A value? Ooh, did you say negative 2? Negative 2, which means to go up or down? Down, okay? Watch that, okay? Because if it's negative, you got to go down. So we would go down 2, right 1, and then reflect it over. Okay. Now what I need is I need 1 more point that I can reflect over, right? Because I have 3 and I need 5. If I look, do I already have a y-intercept? Yeah, okay, so I'm good to go. I can literally pick any other point that I want to, okay? I would pick something close, but you don't have to. So I would pick maybe negative 3 or 1 or something easy. You want to pick 1? Okay, let's do that. Okay, y equals negative 2 times 1 squared minus 4 times 1 plus 6. Zero? Ooh, great. So you're telling me we got the point 1, 0? Sweet. reflect that over. What do you notice about those 2 points? Those are x-intercepts, right? So we got kind of lucky. We didn't have to do any math to find those x-intercepts, and we just got 2 really easy extra credit points. Or sorry, 1 really easy extra credit point on that one, and then 1 on the other one. So yeah, 2.
Wouldn't it be 6?
6 for which one?
The second equation?
You got 6
In my head.
in your head? Okay, make sure that you plug it in. So this would be -2 times 1, which is just -2 minus 4 plus 6 would be 0. Okay. You're squaring the 2. Okay. Cool. And we said our y-intercept was what? We already had that down too. 0, 6. Cool. Okay. What happens if, when I am plotting points, if I don't get those intercepts given to me? Do we remember? We have to plug in 0 for, since it's an x-intercept, you plug in 0 for y. So what you'd have to do actually is just set this up and then do quadratic formula. Yeah, or factor, whichever one you prefer, if it will factor out, okay? So that does happen sometimes, I'm pretty sure on the test, just like this review. I do think that we get whole numbers, okay? So let's say that you graph this and you didn't get those 2, but let's say you picked -4 and you had a point down here, and you could see that your graph looks like it's going to cross through -3. You could just go plug -3 in and check it, right? And get that intercept easily, okay? But if not, you do have to factor. So I just want to make that clear. Okay, vertex, is this a max or a min?
Max.
Max, top of a hill, right? Domain is always going to be -infinity, +infinity. Range, so bottom to top. If we look at this one, y values, what are we doing at the bottom? -infinity, yep, going down forever. So we're starting at -infinity and we are ending at 8. That's the y value that this ends at, 8. Good. Okay, then we have our increasing, decreasing. So we know far to the left is -infinity, far to the right is +infinity. This line is at what number? The line of symmetry? -1, okay? So if I look from -infinity to -1, what am I doing? Increasing. And then from -1 to infinity, I am decreasing. Okay? Questions on that? Is that helpful? Is this starting to kind of make sense, hopefully? Cool. Okay. Number 3. This one is in vertex form. I think by far vertex form is so much easier than standard form, okay? Because it gives you the vertex. You don't have to do any math to find it, right? We start these problems out. First thing we want is the a value, which is the number in front of the parentheses. Is there a number in front of these parentheses? No, it would not be 0, but it would be 1. Yep. So that's going to be 1. A is 1. H is the number inside the parentheses, but again, H is tricky. So if it looks like +3, it's actually -3. And then K is -4. It stays the same. Okay, perfect. So my vertex is just HK, and I already found what those are, right? So what is it? -3, -4. Plot it. Draw your line of symmetry. Okay, a value is still going to mean the same thing here. What do we use a for with standard form? Slope. My slope is 1/1, up 1/1, reflected over. Good deal. Already have 3 points. Need another point? Do I have my y-intercept yet? So I should plug in 0. So y equals 0 plus 3 squared minus 4. Plug that in and tell me what you got. 5. Okay, so the y-intercept would be 0, comma 5. Reflect it over. And there's my quadratic. Just like that. Max or a min? Min, we got the bottom of a hill, right? We call that a minimum. Okay, domain is always, always, always going to be negative infinity, positive infinity, good. Range, so from the bottom to the top, we need to see on the y-axis, where's this starting? Yep, everybody see that? This starts at -4, so that's what we're going to put there. And where's it going? Infinity, going up forever. Okay, x-intercepts. Were those given to us?
No.
No, they were not. Okay, so we basically have two options here. Okay, we can try to see if these are whole numbers. Does it look like these go through whole numbers here? What does it look like they go through? -1 and -5. So could we check and make sure that they do? So plug in one of those numbers and see if it comes out to be 0. So y equals -1 plus 3 squared minus 4. And see what we get. What do you get?
12.
Nope. 0. So it does work, right?
Yep.
Yeah, we got lucky again. Another easy extra credit point right there.
Crazy.
So we got -5, comma 0, and -1, 0. Okay, sometimes it'll go through like a decimal, right? So that's when the factoring thing does have to happen, but we have gotten lucky on all 3 of these. So good deal. Last but not least, increasing, decreasing.
Decreasing.
Hold up, we're gonna have both. What'd you say? Nope, so if you look, -1, 0, and reflect it, -5, 0. Oh, sorry. Okay. So now, last but not least, increasing, decreasing, and where's that line of symmetry at? -3. So from negative infinity to -3, what am I doing? From here to here, what am I doing? What do we think? What do we call that? Decreasing. Negative infinity to -3. And then what about increasing? What would you write right there? Increasing, what'd you say? -3 to infinity. Thank you. Okay, then we're done. Questions on vertex form? We feel confident about that?
Yeah.
Yeah? Okay. We're not going to do number 4, but I will post an answer key to Canvas, okay? Just for time's sake, we're going to get to the other. Okay. Number 5. A child hits a balloon up into the air from a starting height of 8 feet and an upwards velocity of 2 feet per second. Determine how long it takes for the balloon to hit the ground. And it does give us the formula that we're going to use. If you notice, this formula has been simplified from the one we did on the notes, okay? The one we did on the notes, the first term was always -16t squared. This is just going to be -t squared, okay? It's going to make it a little easier to factor and graph, okay? So you can thank me later. It's going to be like that on the test as well. So the first question is just to set up this equation, okay? So what we need to do, our height, or h of t, we'll just put h for now, is going to equal -t squared plus the velocity times t, which what the velocity is for this one is 2, so 2t, good, plus our height, which is 8, good. Gave it to me. So that should be pretty simple. Just setting that up. Okay? And then once you have it set up, this is just another graphing one. So we look. It gives us the graph. It's in which form? Standard or vertex? Like page 1 or page 2? Standard, page 1, right? So we need to start off by telling what A, B, and C are. What's A? B, and C. Perfect. To find the vertex, or find the x value of the vertex, or t in this case, t equals negative b over 2a. What's negative b? Negative 2 over 2 times, what is 2 times negative 1? What is negative 2 divided by negative 2? 1. Cool, my x value is 1, or t value. Now I just got to plug that in to find what h equals. So negative, parenthesis 1, close parenthesis squared, plus 2 times 1 plus 8. So everywhere where I saw a t, I put in the number 1. Tell me what you got. It should be 9. So make sure you put that negative in front of the parentheses. Yep. So negative parenthesis 1, close parenthesis squared, and then plus 2 plus 8. It should be 9. So my vertex then is going to be 1, 9. One comma 9. Okay. My a value is what? Negative 1, so I can use that as my slope. So I can reflect that point down, or sorry, over. How many points do I need though? 5. Okay. So what would you plug in? 3. I would agree. 3 will work. Okay. So if we look, we've used 0, 1, and 2 already. So 3 would be the next one. H equals negative parenthesis 3 squared plus 2 times 3 plus 8. What do you get? 5. Cool. Okay. So that gives me 4 points. Here's the thing though. Since this is a real life scenario and we're modeling a balloon, can a balloon go over into this negative axis?
No.
Unfortunately not. So I cannot reflect this point over. So to find a 5th point, I need to plug in another number. Okay, so I'd pick the next one. I'd pick 4. So we're going to real quick plug in 4. And you get 0?
Yeah, I got 0.
Perfect. That's an intercept, right?
Wait.
No way. We didn't have to do any more math.
Holy cow.
We did not have to factor once today
That's insane.
so far. But I actually don't need to draw this below the axis, right?
Yep.
Since the balloon can't go underneath the ground. Okay, so we're getting close to being done today, guys. We got these 2 questions and then the back page and we're done. Here's our balloon. Does everybody see it? Okay, I was standing on a chair or whatever it says, hit the balloon and went down to the floor. So now I want to know the domain and range and what they represent. Okay, so we'll start by just saying what domain and range represent. Domain represents what? The left to the right. Okay, so on the test it's going to ask you the same question. Just know that domain is left to right. What's range?
Up and down.
Yep, down to up. So bottom to top or down to up, whatever you want to write. Okay? So now I just got to look at this one. And again, we can't do negative infinity or any infinities for this because this is a balloon. It's not going to go to infinity if I hit it unless we were up in space and we didn't have gravity. Okay? but domain, left to right. This is starting right here, but on the x-axis, it's starting at 0 to 4. The range is bottom to top, right? So the y-axis, this is going from 0 to 8, right? Or not 8, 9. It goes all the way up to 9. 0 to 9. It's crazy. Just remembering all of it. It shouldn't be too bad. Okay, part D then says, explain why you got 2 solutions in part A. So basically, if we would have factored that out, we would have got 2 solutions. One would be negative and one would be positive. So they're asking me, why is the negative one not going to work? Basically what they mean, can a balloon go negative?
No.
No, so that's all you need to write. A balloon can't travel in a negative axis. You could put that. Balloon can't go through the earth. A balloon can't travel to negative values. A balloon can't go underground. Whatever makes sense to you, okay? Just know that a balloon cannot go below either axis. Okay, and then last but not least, this is like what we did last class, okay? Super
Hard.
not hard, okay? We should know how to do this already, though. So it gives us the equation. It will give you the equation on the test, too, so don't change this equation. And it says, how long does it take to reach the maximum height? Remember, and I probably will write this up on the board for the test, max time, or time, is negative b over 2a, okay? So how long does it take? It's just negative b over 2a. If I look at this equation, what's the a value? What's the b value? And then if I had a c value, it'd be 0, right? Because there's no constant written. We don't necessarily need that, but good to get in the habit of writing it because it's standard form. So now we just plug these in. Negative b is going to be negative 40 divided by 2 times, 2 times negative 8 is negative 16. So what is negative 40 divided by negative 16? Positive 2.5. Good, 2.5, and we would put seconds. How would we then find the maximum height?
Plug it into the T's.
Yep, just plug it in. So plug in that 2.5 for t to find the height. So the height's going to equal negative 8 times 2.5 squared plus 40 times 2.5. What'd you say? Okay, I'm hearing different things. It's 50? 50 feet? Everybody get 50 feet? Okay. Anybody not get 50 feet? Somebody just told me they got something different. Okay, cool. Last but not least, it says, when does the bullet hit the ground? I've not talked to Mr. Millard, but I think this one might be an extra credit problem too. But we should have to know how to do this. We've talked about it. When does the bullet hit the ground? Think about what they're telling me here.
0.
0, right? For what? The height or the time? The height, because it's the ground, right? The ground is a 0 height, okay? So if I go back up to my equation, I'm just going to plug in 0 for the height value and solve for t, okay? If I wanted to write a plus 0 out here and use my a, b, and c to do the quadratic formula, that's totally fine with me if you enjoy quadratic formula more than factoring. I'm okay with that, okay? But if you're okay with factoring, I would factor here. If I look at that right side, I've got everything set equal to 0, so I'm ready to start factoring. Do I have a GCF here? 5 will go into 8. 8, right? 8 will go into 40, and 8 will go into itself. And since that leading term is negative, I'm going to make it a negative 8. Do they both have a variable in common?
Yes.
T. Okay, so negative 8t squared divided by negative 8t is just going to be t, and positive 40t divided by negative 8t is
5.
negative 5. Yep. I now have two factors. I just need to break them apart, set them equal to 0.
So we can't just put 0 feet?
Huh?
Or when it hits the ground, we can't.
Well, it would start at 0 feet on the ground, but we're saying like after it's been shot.
T equals 8.
How much time has passed basically since then?
Basically,
Okay.
equals all its T's.
So
If it hits the ground, then you do
this one we divide by negative 8, so t would be 0, which we already knew at 0. It started at 0, so that one's not going to matter. The other one we'd add 5 over. T equals
5 seconds.
5 seconds. Okay, let me show you something. Let me show you a little shortcut. Okay, since this is a quadratic and we know that it's got a line of symmetry, meaning that it's equal distance from the left side to my line of symmetry and the right side, you with me?
Yeah.
Okay, so if I know that the x coordinate is 2.5, so meaning from here to here, it's 2.5. Wouldn't here to here also be 2.5? So I could just multiply my value from a times 2, 2.5 times 2, and I'd get 5. That'll work every single time. But if you can't remember that, you do have to do the factoring. Okay? Cool. Any questions on that? All right, study hard.